Does it float? What keeps it from falling out of the sky? Do the wings flex? These are all common questions that I had before I had the knowledge that I do now about aviation or aircrafts in general. These questions might be similar to some of your curiosities. That is why I am here today to inform you about some of the basic aerodynamics of flight, or how an aircraft flies and stays there. I have done extensive research on this topic and have been required to fully comprehend all of its aspects. Therefore, by the time this video is over, I hope that you understand, number 1, the 4 forces of flight, number 2, the 3 axes of rotation, and number 3, the most basic component, how lift is created. The first thing that we're going to talk about is our 4 forces of flight. But first, we must understand the logic in which they work off of, being our 3 laws of motion. These come from Sir Isaac Newton. The first law states that an object at rest tends to remain at rest, where an object in motion tends to travel in the same direction and speed in which it was going. An aircraft that is at rest on a ramp tends to remain at rest until there is a force that is strong enough to overcome its inertia. Newton's second law states that a force is equal to a change in momentum per a change in time, where a force is equal to mass times acceleration. F equals ma is an example of speeding up, slowing down, and entering climbs or descents. Then there's Newton's third law, which states that for every action there's an equal and opposite reaction. With an aircraft, the propeller moves, pushing the air backwards. Consequently, the air pushes the propeller forward. These 3 laws of motion help us understand our 4 forces of flight. The first force being thrust, the forward acting force that is produced by the aircraft's propeller, which is directly related to drag, the rearward acting force. Drag is also parallel to your relative wind being the wind that is just opposite the direction in which you are traveling. Our third force is going to be lift, which is just parallel to whatever flight path you are traveling in. Our last force is going to be weight or gravity, which is just the downward opposing force of lift. The next thing that we are going to talk about is how we actually control the aircraft's flight path, which is directly related to our 3 axes of rotation. Just think about it like this. There are 3 imaginary lines running through your aircraft at all times. One helps the aircraft roll left or right, while the other helps the aircraft turn its nose to change its heading to left or right, while the other helps the aircraft make climbs or descents with a pitching attitude. Roll is going to be on an imaginary line that runs through the nose of the aircraft through the tail. If you can imagine it balancing on this imaginary line, it would simply roll right or left without changing its heading. This is going to be the imaginary line called the longitudinal axis. Next we have our vertical axis, which runs through the top and the bottom of the aircraft, which is called yaw. This movement is just the movement of the aircraft's nose to the left or to the right due to a change in heading. Lastly, we have our lateral axis, which is through the aircraft's wingtips. This is going to control your pitching movement, which is just going to be your climbs or descents. All of these are able to be controlled during flight by the pilot making different movements. Rudder being controlled by your ailerons or your flaps. Then you have your vertical, which is going to be yaw, which is going to be controlled by the aircraft or the pilot using his rudders or the top of his brake pads. Lastly, we have our pitching movements, which is controlled with the elevator attached to the aircraft's tail. Our last main point that we're going to talk about is just the lift and how it is created. Lift is a key aerodynamic force in how the aircraft actually flies. It is produced aerodynamically by air hitting the aircraft's wing or flaps. It is dynamically produced by the wings and the flaps. This is operated off of a principle called Bernoulli's principle. This is when the velocity of a gas or a fluid speeds up, the pressure decreases. It is oftentimes demonstrated through a tube, which I have a diagram to show you. You can see as the tube gets smaller, the velocity will increase while the pressure will decrease. You might be thinking, how is this related to aviation? In aviation, our aircraft's wings are in a similar shape to the tube. The wings have a rounded top and a flat bottom. Therefore, the air that's traveling over the top of the wing must move faster to meet the air moving at the bottom of the wing. Therefore, there is a pressure differential that is created with the higher pressure being on the bottom, creating what we call lift. Altogether, we have talked about our 4 forces of flight, our 3 axes of rotation, and, of course, the most basic component, lift. So just think, the next time someone asks you about the longitudinal axis of an aircraft, you can tell them, this is how we roll.